Yeah, all right. Hello, everybody. My name is Daniel, and I will present a paper about, it's called TENETvr, Comprehensible Temporal Teleportation in Time-Varying Virtual Environments. The other authors are Thorsten Kuhlen and Tim Weisker. So when we want to navigate through time, for example, in a spatial recording or any other time-varying virtual environment, a very simple approach that we can do is just use such a time slider that you can see on the slide here. But you can already imagine that it's very hard to find specific moments in time with such a slider. So a better approach might be, for example, just focus on objects that you are interested in and directly interact with those. So Lilia, amongst others, they did something similar to this. In their system, users were able to just grab objects in the environment. They are then presented with the object's motion trajectory and were then able to grab objects along this motion trajectory to scrub through time that way instead of using this simple slider. So while their approach was preferred over the traditional time slider approach, the problem with their approach is that motion trajectories only visualize location changes. And also, because it's still a continuous time navigation technique, it can be a little bit uncomfortable if many changes happen in a short amount of time. And for me, the biggest drawback was that discrete events like additions, deletions, or any other property changes are still easily missed, right? You can easily scrub over them if you're navigating continuously, although these are actually very common things that we do in, for example, scene authoring. So we thought about pursuing a teleportation-based time navigation technique. And for example, there are papers that suggest to break down continuous recordings into certain key moments. And instead of overlaying these key moments on a time slider, we thought about why not just use these key moments directly as teleportation targets and just teleport directly towards them. But then we also have the problem that many changes happen at once because the transition is instantaneously. So we think we need to assist the user in the task of forming an understanding of the environment during this teleportation process. So what is actually different about time navigation when we compare it to spatial navigation? So in spatial navigation, you have an egocentric viewpoint in a static environment. And in temporal navigation, the user has to comprehend with environmental changes around him from a static view. So many changes. So we wanted to formalize this idea, and basically we suggest that travel techniques through time should assist the user in the formation of temporal awareness, which we defined analogously to the terms of awareness defined by Bauman, amongst others. And we define temporal awareness as the ability of the user to retain an awareness of her surroundings during and after travel to a different time point. So how do we get there? What do we need to do in order to retain the user's temporal awareness? So we looked at the spatial domain for inspiration. So in the spatial domain, if we have spatial teleportation techniques, what is typically done is you add a pre-travel information to foreshadow the relocation of the user, and it looks something like this. So you would render the target location where the user will end up after the teleport and also show a preview avatar of the user. So the user has already a feeling about where he will end up after the teleport is executed. So we took this idea and applied it to teleportation-based temporal navigation. And I will show you our technique in a second, but first we need a time-varying environment that we can work in. So in theory, our technique works with every three-dimensional object that have a version history, but we applied it in this city environment. So we have a city that evolves over time, and as time-varying object, we used just buildings with different properties like color, size, and location. And each building has a list of changes, property changes with an accompanying timestamp. So this is what our interface looks like. We call this TENETvr. And so the first step of the user is that he selects an object he's interested in, and he is then presented with key moments that basically visualize the reversion history of this building. And you can see that the building increased in size and the color changed. And yeah, so we have text above each key moment that basically state what property changed and also at what time point. There's also a small icon that visually represents the property change. We have a world in miniature below just to give the user a better overview of the environment. And these rays then indicate the current active key moment and also connect the representation of the object in the world in miniature to the object in the real environment. So yeah, the user can then go ahead and grab one of these key moments and is then presented with a visualization telling the user how the world would change if he would traverse through that. If he lets go, then the visualization disappears. And it's not just visualized on the building he interacts with, but in the whole environment, because it's a global transition, right? So you can see all the changes that would happen. They're also displayed in the world in miniature. And if the user presses the trigger, the time jump to that new point in time is executed and the rays update accordingly. So we added visualizations for 9 different types of property changes, adding and removing of floors. We have adding and removing of these fire escape balconies, which served a little bit as a proxy for adding smaller details. We have size changes, color change, initialization or deleting of a building. And we have this location change. So there's this ray drawn from the old position to the new position. And in the last picture, you can also see that we can visualize multiple property changes at once. So in that case, the building got moved to a new location, some floors were added, and these fire escape balconies got removed. So we did a user study to evaluate the comprehensibility of this pre-travel information and wanted to look, does it actually help retaining the user's temporal awareness? And so we had 20 participants, and it was a within subjects design user study. And we had 2 conditions. In both conditions, this TENETvr user interface was shown. So the key moments in the world in miniature was present in both conditions. But in the first condition, grabbing a key moment would show the user this pre-travel information. And in the other condition, there was no pre-travel information present. And we then asked users to find changes between 2 points in time. So I have a video about it. So users were positioned in front of a building. It was marked by a green arrow. Then they activated our TENETvr system by just pointing at the building. And then we marked 2 key moments, which were interactable. So users only performed a single time jump. And then they had to basically look around the environment and tell the experimenter which property changes they see. So for example, oh, this building over there had floors added and its color changed. Here a building was deleted. So it wasn't, we didn't require participants to say exactly 2 floors were added. It was just about having a general idea which property changes were happening around the environment. And yeah, so, and also they clearly communicated when they think they saw all the changes, and then we would move on to the next task, basically. So in total, we had 30 tasks. Each task had 1 to 5 changes scattered across 1 to 3 buildings. So sometimes a building had multiple changes incorporated, and the buildings were scattered in different directions relative to the user. And we hypothesized before the user study that the added pre-travel information will reduce the number of time jumps the user have to execute to see all the changes, and as well, reduce the task duration. In general, leads to a better change detection task, reduce the task load, and improve the user's experience. And yeah, the results were quite clear. So with the pre-travel information present, obviously participants found more correct changes. So they made fewer errors in telling us which property changes they saw. They had to perform less time jumps, so less jumping back and forth to figure out the changes. The average time it took them to find all the changes was lower, and the task load was also lower with the pre-travel information present. And also in the user experience questionnaire, we can see clearly that the added pre-travel information was generally preferred. I know this is a little bit Captain Obvious. Obviously, it's easier and faster, but we were still surprised how clear the results were. And we kind of expected that the task load and the user experience questionnaire would be a little bit closer, since the added pre-travel information could also clutter the scene or irritate the user, but that doesn't seem to be the case. So yeah, what we haven't done, so what's still up for future work, we haven't compared our technique to other time navigation techniques, and we kind of need to also didn't evaluate different types of visualizations for this temporal pre-travel information. And also we have to look more into this concept of temporal awareness as a whole. So our change detection task gives us some indication about retaining temporal awareness, but it might not do this more complex concept justice. So we need to look into that a little bit more, I think. So to summarize, the main contributions are that we derive this quality requirement. If we want to do teleportation-based time navigation techniques, we need to look into temporal awareness. We introduced our interface and we realized a temporal pretravel information. And yeah, we did a user study to evaluate that its kind of situation is somewhat effective and improves comprehensibility and therefore reduces temporal awareness. That's it. Thank you so much.
Break went over.